Hey, every day we make choices. Which product should I buy? How much should I consume? But have you ever wondered why we make these decisions? In economics, consumer behavior studies how individuals make choices based on their wants, income, and available goods. Hey everyone, this is Pritom, a computer science major in Shahjal University of Science and Technology, and this video is an assignment on the course of Principle of Economics. The chapter we're going to talk about is consumer behavior. Here's the chapter plan laid out in front of you. The key points are utility and choice, consumers, equilibrium, income consumption curve, and water diamond paradox. In utility and choice, we're going to talk about cardinal versus ordinal utility, total utility and marginal utility, TU and MU, relationships between TU and MU, law of diminishing marginal equality. And for consumers equilibrium, we're going to talk about indifference curve and budget line, marginal rate of substitution MRS, consumers equilibrium. And for income consumption curve, we're going to look at angle curve, derivation of consumer demand curve, and the last topic is water diamond paradox. After watching this video, we will learn about utility concepts. We can differentiate between cardinal and ordinal utility. We can explain total utility and marginal utility, analyze the relationship between total utility and marginal utility, and apply the law of diminishing marginal utility in real life. Determine consumers equilibrium, interpret indifference curves and budget lines, explain marginal rate of substitution and its role in decision making. We see this every day in our daily life. Derive consumers equilibrium mathematically and graphically. Analyze consumer choice and demand. Understand the income consumption curve and derive the angle curve. Explain how consumer demand curve is derived. Resolve the water diamond paradox. Understand the paradox and how marginal utility explains the difference in value. Overall, this chapter helps explains how consumers make choices and how demand curves are formed based on utility and income effects. I hope we're going to learn something new in this video. Have you ever wondered why we choose one product over another? What makes a cup of coffee in the morning so satisfying? That feeling of satisfaction comes from what economists call utility. Utility is the satisfaction, pleasure, or benefit a person derives from consuming goods and services. In simple terms, anything that gives you satisfaction provides utility. For example, a slice of pizza is utility, a new smartphone is utility, a comfortable chair is utility. But how do we measure utility? Can we put a number on happiness? Well, happiness depends on person to person, but economists use utils, a hypothetical unit, to quantify utility. More utils means more satisfaction, fewer utils means less satisfaction. For example, if eating a burger gives you 10 utils of satisfaction, but a mere vegetable salad only gives you 6, we can say that burger provides higher utility and the vegetable salad provides lower utility. But remember, utils are not real-world measurements. They simply help us compare preferences. Imagine you are eating slices of pizza. You're very hungry and you just got a very good pizza. Now, For the first slice that you were eating, you would get more satisfaction, and it would be as you were hungry, this would mean very high utils. For the second slice, you are still hungry, but you can't eat how you were eating the first slice of the pizza. And as you continue to eat, for the fifth slice, you can't eat anymore because you're full. So there, the satisfaction level is, we can say, 0 when you're full. And at the sixth slice of the pizza, you're just overeating and you can't handle any more slices of pizza. And this is not satisfying. So it can be minus utils or negative utils. So next time you enjoy your favorite food or buy something new, think about it. You're making choice based on utility. Now, how do economists measure satisfaction? There are two approaches, cardinal and ordinal utility. Cardinal utility assumes that satisfaction can be measured in numbers. For example, eating a burger gives you 10 utils, while sandwich maybe gives you 6 utils. More utils means more satisfactions. And ordinal utility, instead of numbers, ordinal utility focuses on ranking preferences. You might prefer coffee over tea, or you might prefer burger over vegetable salad. But we don't assign exact numbers in ordinal utility, just order them. Let's look at some differences between cardinal and ordinal utility. Cardinal utility assumes utility can be measured in numerical units, utils. This is an hypothetical unit, we have talked about this before. And ordinal utility assumes consumers can rank preferences but not measure them precisely. For cardinal utility, we use a measurement to quantify our satisfaction, and that is utils. And in ordinal utility, we do not assign any numbers to them. Like I just prefer tea over coffee, but we do not assign numerical values when we are talking about ordinal utility. For example, a person gets 10 utils from an apple and 20 utils from a banana, meaning the banana gives twice as much satisfaction as an apple. For ordinal utility, we can think this about like this. A person prefers banana over apple, but we do not know how much. Let's look at some real-world use differences between cardinal and ordinal utility. Cardinal utility is used in older economic theories and utility-based pricing models, but ordinal utility is used in modern consumer theory and behavioral economics. And in real life, ordinal utility makes more sense because, for example, I like a banana 10 utils, but you could like a banana more than me, and that would be like 20 utils. So it is the same banana we're talking about, but you are assigning a bigger value to the same banana. So the limitation is here for cardinal utility. It assumes utility can be precisely measured, which is unrealistic. And for ordinal utility, it is more realistic to say it cannot measure intensity of preferences, but only the order. Okay, let's see what is total utility and what is marginal utility. Total utility is the satisfaction gained from consuming a certain quantity of goods or service. This is measured in utils. And the marginal utility is just a derivative of total utility. Marginal utility is the additional satisfaction gained from consuming one more unit of goods and services. So what does it mean by consuming one more unit of good or services? In the previous example of the pizza slice or pizza eating, we have seen that uh, at after eating one slice of pizza, after eating one more slice of pizza, how our satisfaction level goes down. And this is called marginal utility. That marginal utility refers to that if we eat just one more unit, or if we consume one more unit of any good, what would be our satisfaction level. And total utility just talks about any satisfaction level at any point of time. And marginal utility is just the derivative or the slope of the total utility curve. Here we can see two total utility curves and their respective marginal utility curves. For the first curve on the left, we can see that as we are consuming more goods, our satisfaction level is increasing. But this will not indefinitely increase. At some point, we would reach an equilibrium where we are not satisfied getting one more amount of that good, and this could be dissatisfying even. So here we can see that when the TU curve changes its course, it is called the point of inflation. And what does it mean by point of inflation? It means that as we are consuming more goods, at the point of inflation, our marginal utility was the highest. That means if before the point of inflation, as we are consuming one more good, our satisfaction level was increasing in increasing rate. But as we reach the mu max or the point of inflation, mu max or the point of inflation, we are at our most satisfied level. And after the point of inflation and before the TU max, our satisfaction level is still increasing, but it is increasing at a decreasing rate. And at TU max, where our satisfaction level is highest, after TU max, the satisfaction level is going down. That means at TU max, our marginal utility is 0. And after consuming one more good, we are not really getting satisfied, and in this case our satisfaction level is also decreasing. So at that point, at TU max, the marginal utility becomes 0. Remember what marginal utility was? It was that what additional satisfaction can we gain from consuming one more unit of good and service. So we can see at TU max, if we consume one more unit of good, our mu, our marginal utility, is decreasing at that point. So in the TU max region, the marginal utility becomes 0. If we look at the right graph of TU versus mu, we can see that our TU curve was increasing, but it was increasing in a decreasing rate. And our mu curve is a straight line. Here also you can see that our TU max is where the TU or the total utility is max, our marginal utility is 0. From these graphs, we come to the following conclusions. The point of inflation is where the TU decides to change its course. This can be found in the second derivative. Mu is the maximum where the point of inflation is found. This is true, we can see it in the graph. Mu or marginal utility is 0 where TU is maximum. When TU increases at an increasing rate, the mu rises, but when it increases at decreasing rate, the mu falls. When TU is decreasing, mu is less than 0, and this is also a case we can see it in the left and right graph also. After the TU max, our TU curve is decreasing, and we can see in our marginal utility curve that the marginal utility after TU max is negative or less than 0. Now, what is the law of diminishing marginal utility? As a consumer consumes more units of good, the additional satisfaction or marginal utility from each extra unit decreases. This is where our pizza case arrives. When we're eating pizza, as we're eating more and more pizza, our satisfaction level from each extra unit always decreases, and this is true for anything. Like when you have a lot of money, you can buy many smartphones, but the satisfaction level of getting your first smartphone is more than when you have more money and you can buy more gadgets and more smartphones. And the satisfaction level is not that good when you have like 3 or 4 smartphones. At the fourth smartphone, you would just get bored, like it is the same. Total utility increases as long as marginal utility is positive. Marginal utility decreases as consumption increases. Eventually, MU or marginal utility become 0 or negative, meaning that consuming more does not provide extra satisfaction, or even it results in dissatisfaction, as we have seen in the previous curves. Now, consumer equilibriums is another case. In consumer equilibrium occurs when consumers maximize their total satisfaction or utility given their income and price of their goods. When the income increases, a person can buy more goods, or when the price decreases, a person can buy more goods. This is true for any goods in this world. At this point, they have no incentive to change their consumption pattern. For a consumer to be in equilibrium while consuming one good, they should consume up to the point where mu is equal to p, where mu is the marginal utility and p is the price of good. So marginal utility of the good is equal to price of good, and that is the point when consumer equilibrium occurs. If the marginal utility is greater than the price of the good, consumers should buy more of the good. And if the marginal utility of the good is less than the price of the good, consumer may buy less of the good. How do consumers decide between different combinations of goods? Indifference curves and budget line help explain this. An indifference curve is a graphical representation of different combinations of two goods that provide the same level of satisfaction for a consumer, meaning the consumer is indifferent between any points of the curve. Now here we can see at the right side of the screen that there are 3 IC curves. What is the significance of 3 IC curves here? The significance is that the x-axis is for a good, any good, and the y-axis is for another good. So let's say me and my friend are having a burger and having burgers and sodas. Okay, so I am going to rate the burgers 10 utils, let's say, and my friend is going to rate the burgers 20 utils. So my IC curve will be the lower IC curve, and my friend's IC curve will be the higher IC curves. The main key point here is that even if we assign different utils for different goods, the IC curves shapes shouldn't change. The budget line represents all possible combinations of two goods a consumer can afford given their income and prices. Let's say you have a budget of $10 and you have gone to a coffee shop where they sell coffee and donuts. So if you have a budget of 10, you can have one coffee or two donuts, or like you can have no coffee or three donuts. So this line that represents the relation between your consumption and your budget is the budget line. So if we see at the right on the graph of the budget line, there is a point under the budget line and there is also a point above the budget line. If the point is under the budget line, we call it unutilized. That means you have spent some money on two goods and you have a remaining budget that you can spare more on. And if the point is on the budget line, that means you have spent all of your money or all of your budget to buy these two goods like coffee and donut. And if the total consumption is above the budget line, that means you cannot afford it. Like you cannot afford 10 coffees and 10 donuts using your $10 because 10 coffees would cost $40. You just have $10. So when the point is above the budget line, this is out of your capacity. Now we can combine the budget line with the IC curve. A consumer's optimal choice is where the budget line is tangent to an IC curve, and that is the point of consumer equilibrium. Here on the right side of our screen, we can see that our budget line actually touches two of the IC curves, but it is only tangent with IC2, and it is tangent on the E point, and that is the optimal point, and that is the higher IC. Why we are not saying that the point A and B are not the optimal points, although point A and point B are on the same budget line? Because what we are trying to achieve here is maximizing our total utility, and these are total utility curves, as we know. So when we want to maximize our satisfaction, we cannot say A is the best for our satisfaction, because in this curve we can see that E point is more better than A. You can have both A and you can have both goods and have more satisfactions at the point E. So, and for the points D and F, we can see there are also some points D and F on the IC curve at where the budget line is tangential at that IC curve. There are 2 points D and F that are not optimal because although they are on the same IC curves, but they are unattainable for you. They're out of your budget. So D and E points are also not our optimal points. So our conclusion is, although A and B points are in the budget line, we are not saying that they are our optimal points, because if we see that E gives us more satisfaction, and for the D and F points, although they are on the same IC curve, we are saying that they are out of our budget and we cannot achieve that level of satisfaction, like D or F level satisfaction. When making choices, consumers often trade one good for another. But how much of one good are they willing to give up to get another? That is where marginal rate of substitution or MRS comes in. MRS is the rate at which consumer is willing to substitute one good for another while keeping the same level of satisfaction. Imagine you love both coffee and donut. You are willing to give up 2 donuts for one extra cup of coffee. As you consume more of one good, MRS usually decreases because of law of diminishing marginal utility. This helps shape consumer preferences and indifference curves. MRS is equal to del of x2 divided by del of x1 into -1. So what does this mean? This means that the amount of x2 you are willing to give up for getting more x1 or vice versa. Now, what happens to a consumer's choices when their income changes, when their income increases or income decreases? That's where the ICC curve or income consumption curve comes in. The income consumption curve shows how a consumer's optimal consumption for two goods changes as their income increases or decreases, assuming the prices stay constant. When income rises, the consumer can afford more of both goods, shifting the equilibrium points. When income falls, the consumer buys less. So when the income falls, when the income rises, this allows our budget line to rise, and when the income falls, this allows our budget line to fall. Now, what's the link between income and demand? The angle curve shows how a consumer's demand for good changes as income increases. So, for normal goods, as income increases, demand increases, upward sloping angle curves. And for inferior goods, as income increases, demand decreases. For example, when you were economically challenged, you would have eaten instant noodles, for example. But when you are more able or your salary is a good amount, you avoid instant noodles. So for inferior goods like instant noodles, the demand for this type of goods decreases as one's income increases. And for any type of food that is good or any normal goods, like for example a ramen, when your income was less, the demand for ramen or ramen noodles was high for you. And when your income is greater than before, then also, as the ramen is a good product, your demand for ramen stays the same or even increase. So for better goods, as the income rises, demand increases, and for inferior goods, as the income rises, the demand decreases. Let's look at an interesting paradox. Why is water, which is essential for life, so cheap, while diamonds, which that have no regular uses in our life, we do not need to survive on diamonds, but why are diamonds so expensive? This is what diamond paradox, also known as paradox of value. The paradox is that water has high total utility. We need it daily, but it has low marginal utility. Since it's abundant and an extra unit does not add much value, while diamonds have low total utility. We do not need them to survive, but high marginal utility. They are so rare that an extra unit is highly valuable. The price is not based on total utility, but actually on marginal utility. And we can see this in the examples, in the equations in the bottom. Previously, we have seen that the marginal utility, the ratio between the marginal utility and prices for any goods in this world always stays the same. It's a constant. For any goods, the ratio between the marginal utility and the price is always the same. So if we are seeing the marginal utility of water, the marginal utility of water is low. So the price of water is low. And to keep this constant equal to the marginal utility divided by price of diamond, we know that the marginal utility of diamond is very high. So to keep this constant, we need to raise our price of diamond. So if the ratio between marginal utility of water and price of water has to stay the same to the marginal utility of diamond ratio, the price of the diamond, we need to increase the price of the diamond as the marginal utility of the diamond is more. Hey everyone, thanks for watching. Do like, comment and share.